Hi, my name is Mike Scott, Industrial Product Manager for the Modal Shop. And in this video, I'm going to show you how to test Meggitt CA202 Differential Charge Accelerometer paired with a Meggitt IPC704 Differential Charge Amplifier. Now, the 704 has been replaced by the 707, but for our purposes, the functionality is the same. You commonly find this instrumentation on Siemens gas turbines. And in the video, I'm going to show you how to test these two items as a system with the output of the signal conditioner in the scale of inches per second and AC current. We'll also break it down and show you how to test the accelerometer by itself. The first step in mounting the accelerometer is to put some silicone grease on the top of the shaker, and then we install the supplied multi-hole mounting pad. Looks like this, and it's drilled for the holes, the bolt pattern for this accelerometer, and the thread of the supplied bolts. So we just screw the center stud in here, like so. And then before we tighten it, we always want to make sure to use the supplied mounting wrench. Be sure to get that around the base of the shaker and tighten. About 10 to 15 inch-pounds of torque is fine. The next step is to apply a little more silicone grease to the top of the mounting platform. And then we put our accelerometer onto the top. I like to spread the grease around a little bit underneath. And then we just get started with the bolts. It's a 4-bolt pattern. And we just get one started, get another one started, grab another mounting wrench that fits, tighten, and once again, I like to use a supplied mounting wrench just to be safe. We get this around the base and we tighten each one of the bolts. The CA202 accelerometer has 3 wires. Blue is positive signal, white is negative signal, and green is the case wire. In order to test this as a system with the IPC704 Signal Conditioner, we want to connect the blue wire to the input positive signal terminal. Connect the white wire to the input negative signal terminal, and then let the case wire float. Do not connect anything to the common terminal. This will prevent a ground loop in testing. On the other side of the 704, we have the output of the product and the power input. This will be provided by the model 9100 PSO2 signal conditioner and power supply. This power supply made by the Modal Shop plugs into the USB port on the Portable Vibration Calibrator and provides 24 volts DC power to the 704. On the 704, we connect the plus 24 volt DC power terminal to the plus 24 volt terminal on the 9100 PSO2. Then we connect COM to the SIG-in terminal of the 9100 PSO2. The 9100 PSO2 will pass the signal from the IPC704 over a 500 ohm precision resistor, and we can measure the sensitivity of the system from there. Here's a wiring diagram for the test. To test the accelerometer and signal conditioner as a system, I've connected the output of my 9100 PSO2 to the test sensor input of the shaker table, and I've turned the charge on-off dial to off. The next step is to make sure that the resistance value of the 9100 PSO2 is set correctly in the shaker's options. I rotate the file button until I see Tools, then click Options, then check Set Resistance Value. I can see it's correctly set to 500 ohms. If it were another value, it could be adjusted. I'll hit back again, and one more time. And now I need to go to my test settings and make sure I'm set up to calibrate a modulated current output. That's an AC current output. So I change my sensor type to mod cur. Everything else is correct. Press the back button 2 more times. And now I'm correctly scaled in the inches per second vibration scale, shaking at 100 hertz and 1 inch per second peak. And you can see that the sensitivity of my IPC704 coupled with the CA202 accelerometer is 1.53 milliamps per inch per second. The target sensitivity was 1.54, so we're very close to a perfectly calibrated value. I can also perform a quick test routine with automatic pass-fail notification by pressing frequency, going into my test settings, choosing Cal route, and activating the test for the IPC704. From here, any technician could perform this test. We're shaking at 0.5 inches per second peak at 160 Hertz. We press the button and it says pass. Press file again to move to the next point at 100 Hertz. And again, 1.54 milliamps per inch per second. And we pass again. And so on until the test is complete. A Pomona 3788 works very well for testing the accelerometer by itself. A Pomona 3788 allows us to use these clips to attach one of the signal wires and the shield to the black lead, and then signal positive to the red lead. And the other side of our 3788 is a BNC connection to the shaker. Disconnect the portable vibration calibrator from the charger during this test, as having the charger connected will create a ground loop. To test the sensitivity of the accelerometer by itself, we have it connected to the charge input. The first step is to pause the shaker, enter the test settings menu, and make sure that our sensor type is set for charge. After that, we hit the back button. You can see I'm already in the G's peak scale amplitude. My frequency is 102. I'll just lower it to 100. And the sensitivity of my CA202 is 98.15 picocoulombs per G, which is well within tolerance. If we want a quick pass-fail test, all we need to do is press frequency again, go to the test settings where I have already loaded a CA202 test very quickly, choose the sensor model number, hit the back button. Now I have a pre-programmed test routine that will tell me whether the sensor passes or fails at each one of my test points. The most important thing to remember about testing the CA202 accelerometer and the IPC704 with a portable vibration calibrator is in regards to the case wire, the green wire. When we test the accelerometer and the signal conditioner together, we want the green wire to float. And when we test the accelerometer by itself, we want to tie the green wire to one of the signal wires and then have the other signal wire on the center pin of the BNC. Hey, thanks for watching. For more informative videos, please check out our learning portal.